Okay, in this second video, we want to prove another theorem showing that two sets are equal. In this case, the theorem is one of what's called De Morgan's laws. And on the worksheet that you should be doing this week, you'll see that I have you prove another one of De Morgan's laws. And De Morgan's laws have to do with complements, how complements behave with unions and intersections. And so this theorem says that if you have two sets A and B, and you can take their union first and then take the complement, and that will be equal to if you take the complement of A and the complement of B and then take its intersection. So again, before we prove this, I want to just make sure that we believe that it's true. So we're just going to draw some simple pictures first. So we have A union B here. So we have A and B. And if I just union the two of them, then I'm just talking about this guy here. So that's A union B, right? Okay, but if I want A union B complement, then the picture is, again, I'm using the rectangle to denote some universal set. I have A and B. I want A union B complement. So I'm looking at everything outside of A union B, right? So we're talking about all this stuff out here. Okay, so that's A union B complement. Okay. On the other side, I'm supposed to take just A complement. So let's again draw A and B, but we're just going to look at A complement. So here's A and B, and if I use a different color, so A complement is just going to be everything outside of A. So that's A complement, and then B complement will look like let's use a different color. So B complement will just look like okay. And so now the point is that if I take the intersection of sorry, one more thing. This is B complement. And if I take the intersection of A complement with B complement, then I just get everything which is in both A complement and B complement, right? So then that's just what we get over here, right? So that's the same thing as A complement intersect B complement. Basically everything outside of A union B, right? Because over here, this part is not included up there, so it wouldn't make it to the intersection. What's up here in yellow inside of B is not down here in B complement, so that doesn't make it in the intersection. And so we can see just by drawing pictures that this theorem looks believable, right? But again, these pictures could be deceiving us, and these pictures are really just drawn in a very special way. And so now, in order to know that this theorem is true, no matter what sets we take, we're going to give a logical proof. Okay, so now let's look at the proof. Let's tell the reader what we want to do. So we want to show that A union B complement is equal to A complement intersect B complement. Okay. First, we will show that A union B complement is a subset of A complement intersect B complement. Okay, so to this end, not a lot of thinking here in this the beginning strategy. It's a direct proof, but there is a little bit of strategy where we just show that one is a subset of the other and the other one is a subset of the other. And so that's the strategy, is just to show that both sides of this equality are subsets of each other. We start by showing that the left-hand set is a subset of the right-hand set. And then if you want to do that, you just have to say, let X be in the left-hand side. Okay, so then got to start unpacking the definition. So by definition of complements, we know that X is not in A union B. Okay, now this is a little bit funny because now we want to use the definition of union, but we want to use it in the negative. So let's just think about what unions mean, right? So by definition of union, if X was in A union B, then X is in A or X is in B. So the point is, so if X is not in A union B, then it can't be in A and it can't be in B either. So, because if it was in A, then it would be in the union. And if it was in B, then it'd be in the union, right? And since it's not in the union, it must be the case that X is not in A and X is not in B. Okay, but now we want to use the definition of complements again. So by definition of complements, this implies. So now we know that X is in A complement and X is in B complement. And we're almost done with this case now. So that by definition of set intersection, we see that X is in A complement intersect B complement. And so we're done with this case, right? So we have shown that A union B complement is a subset of A complement intersect B complement. Again, we started with an X, which was in the complement of A union B, and we showed that that X is also in A complement intersect B complement, and that's how you show subsets. Okay, so we're done with that direction, and now we want to show. So now, oops. Now we want to show that A complement intersect B complement is a subset of A union B complement. Okay, to this end, let X be in A complement intersect B complement. Okay, now we have to unpack some definitions. So by the definition of set intersection, we see that X is in A complement and X is in B complement. Okay, now by definition of set complement, X must be not in A and X is not in B. Okay. But again, before we used the definition of union in a similar way, right? If you're not in A and you're not in B, then you can't be in the union of A and B. So by definition of union, we find that X is not in A union B, right? Because if X was in A, then it'd be in the union, but that would contradict the fact that it's not in A. And if X was in B, then it'd be in the union, which would contradict the fact that it's not in B. Um, so X cannot be in A union B. All right, but now we just have to apply the definition of complements one more time. So by definition of set complements, we find that that means that X is in A union B complement. So we have shown that A complement intersect B complement, the subset of A union B complement, since both A union B complement is a subset of A complement intersect B complement, and A complement intersect B complement is a subset of A union B complement. We see that A union B complement is equal to A complement intersect B complement. That's the end of the proof. Okay, so that's one of De Morgan's laws. The other one of De Morgan's laws I'll have you'll prove on the worksheet, which says that A intersect B complement is equal to A complement union B complement on the worksheet. Oh, I can't spell right now. On the worksheet. But I just want to point out that these De Morgan's laws are kind of like giving you some algebra that you can do with intersections and complements. So one way you can think about this is that the complement distributes over a union. And when you distribute the complement over a union, it becomes an intersection. And down here, the one you're going to prove on the worksheet says you can distribute a complement over an intersection. And when you distribute a complement over an intersection, it becomes a union of complements. So these De Morgan's laws are telling us that there's some algebra of set unions and intersections and complements. Okay, that's it for this video. In the next video, we'll look at one more exercise where we prove two sets are equal.